So for the next 2 hours or so, we're going to cover post-tension concrete and effectively the principles in the sense of how it applies to building design, building construction, stuff like that. I'm not going to go into a whole litany of theories and interesting differential equations, but basically how this works in the design office, why we use it primarily as a design tool, why it's beneficial to concrete structures, and hopefully if you're new to post-tensioning and really have no idea what I'm talking about, you'll know slightly more than you did before in about 2 hours or so. As Maria mentioned, we do have two Q&A sessions prior to the end of the seminar, so if you do want to ask any questions, please feel free to do so, and I'll get to those at the breaks. My email address is listed on the bottom of this slide and the last one, so if something does come up at a later date and you want to ask a question, 2 hours from now and 2 years from now, feel free to send me an email and I'll get back to you as soon as I can. So moving forward, most of the information I'm going to cover is either directly or indirectly in the book that we wrote during the recession a few years ago, and my business partner and I have updated it throughout the last 10 years or so. The first half of the book, if this webinar is interesting at all, is basically what you should be looking at. That is the first half of the book is what we use for the undergraduate concrete course, which is actually starting next week in both, primarily for us right now, UCLA and Cal Poly SLO. Use the book, and like I said, they're going to start next week. So if you're interested, there's a lot more stuff about this topic in those chapters and pages. First of all, if you're new to post-tensioning, there's a lot of myths about PT that are propagated throughout the whole system. It's funny because I've giving a lot of webinars and prior to COVID, a lot of seminars, and these myths, from Los Angeles to Boston to Hawaii still exist. The biggest one is post-tension concrete is crack-free. That is completely untrue. Concrete is concrete, whether it's rebar, whether it's precast or post-tensioned. Concrete's going to crack, and that's okay. I mean, the entire basis of reinforced concrete design in terms of ultimate strength is based on the concrete straining enough, moving to activate the rebar, which any kind of movement of concrete is a crack. Just because concrete cracks and that concrete is post-tension does not mean it's a failure, does not mean everything's going poorly. It's the nature of the beast. Now, obviously, less cracking is better. No one's going to deny that. But saying that someone trying to sell you that post-tension concrete, if A, designed well and B, constructed well, is crack-free, it's just completely false. The other thing is people say a lot, and this comes a lot of times from contractors, is that PT is waterproof. That somehow if you take an 8-inch slab at 5,000 psi and put floors at 9 inches on center, top, and bottom each way, it's not waterproof. But you take that rebar, you put in some 200 psi of pre-compression, all of a sudden it becomes magically waterproof. That is not true in the case. It does not enhance waterproofing. If anything, you put too much post-tensioning in, and that causes more cracks, and cracks are never waterproofed. It is a great material to, if done correctly and built correctly, should minimize cracks, but it's never going to be waterproof, and never assume it's going to be. If you want waterproof, membranes, applications, chemicals, stuff like that, but PT is not going to buy you waterproof. I don't care what anyone tries to sell you. The other thing from a numerical standpoint is that if you do PT, you drape the tendons, you put force into the system, and you create balanced loads, which I'll cover in a little bit, that somehow that reduces the weight of the building, reduces the load on the columns, and obviously subsequently the foundations. That is a numerical misunderstanding, which I'll cover in a little bit. Basically, an 8-inch deck of concrete weighs 100 pounds a square foot. Partitions are 20 pounds a square foot. Live load is 72 pounds a square foot, whatever it is. That weighs what it weighs. Whether you have rebar or post-tensioning or steel or wood, those weights never change. It's a numerical hocus pocus. The weight of the building is never altered by post-tensioning. There may be some slight distribution differences from just straight, trib area or continuity of indeterminate structures, but it never actually changes appreciably the weight of the building. So make sure you don't get caught doing that. The other thing is, if you drill into a PT building, that it's just, no, you cannot do it. God himself could not come down there and drill in a PT building. Now, having said that, we do it all the time. Bolts are missed, rebar is missed. I mean, I answered an RFI today where they missed some bars in a masonry, a series of masonry walls that they have to epoxy in. It happens. It's the nature of the beast. Nothing in construction is ever perfect, just like our drawings are never perfect. The thing is, you have to adjust the location of those drills, be cognizant of the fact that you don't want to drill through a piece of post tensioning in the same way you don't want to drill through a piece of rebar if you can avoid it. The major difference is PT is very similar to a rubber band, that if the rubber band is 2 inches long or 25 inches long, if you cut it at one location, you'd lose the entire rubber band. Now, obviously with rebar, if you drill through a number 5 bar completely 3-4 feet away from the drill location, it will redevelop. So you have some forgiveness there. With PT, you lose the whole thing.